Hey, what's up, Ziguanas? This is a special edition of the 30 Days of the Coding Challenge, and it is special because today I'm not going to go through the docs and I'm going to practice what I have learned for the first 25 days of my learning Zig voyage. My name is Dusan. Welcome to Zignited. So like I said before, but I will mention one more time for maybe the ones that are here for the first time. I didn't have any Zig experience 25 days ago, 0 lines of code written, and then I started my learning voyage and I documented it here live in stream. So that was the idea, that I document my voyage, and I thought it might be interesting to some people because I do have a lot of professional programming experience. I've been coding for more than 2 decades professionally, so getting paid for it. And I also received first money from for teaching someone else to code around 15 years ago. So I've been doing that also constantly in the last 5 years for sure. But before that, it was more like occasionally from time to time. So my focus was before just to code. Not just, but mostly to code, and then to teach when I have time. But in the last maybe 5 years, I've been doing much more of these, like mentoring, tutoring, and so on. So that's about me. So today I'm going to code this. I called it N in a line in Zig. It's this game I will show you on the screen. So it's typically called Connect 4 or 4 in a line. It's a physical game, so you buy it as a physical game, and there are 2 players which alternate and they switch turns, and you have this concept of gravity, right? Because you throw in your piece from the top and the piece will always fall to the bottom. So it's kind of like tic-tac-toe, but you have this additional interesting part that is gravity, that is interesting to code, and it's larger, so it's going to be more interesting to code the rules and checking the winner situation. So that's why I decided to do this as the next stage. So my idea is to code this game, so of course without UI, so I would just code the logic. Maybe in the future it will be interesting when I finish these 30 days of coding challenge. Maybe I can do then something with WebAssembly. So I haven't touched WebAssembly here with Zig yet. I did WebAssembly with Rust like 6 years ago, I think. I played with it a bit. So I could maybe at the end do some WebAssembly integration and then maybe make a user interface in JavaScript so that we have graphically something that the Zig calculates everything, the Zig language calculates everything in the backend, not in the backend, but I mean behind the scenes, let's say, so still in the browser, and that JavaScript just like shows the pieces on. But like I said, this is not what I'm going to do today. Today I'm just going to do the logic, the rules. So we're going to print a bunch of things instead of doing the graphics, and because I'm also going to use still this web playground on zig-play.dev. I don't have any access to file system here, so I will not save state. So let's say this is going to be the first first video of a series about this game. So in the first today, so what's the goal for today? I want to do the logic, that we have something that runs and that the game that works. If I manage to do that in the next hour and a half, maybe 2. So if it takes longer, maybe I will pause even before I have a working prototype and then continue next time. And then for sure in some of the next streams, I will add this file, let's say saving a game, so that you can start multiple games and then continue one of them. And then as the last stage, I will do some user interface, maybe in WebAssembly, so we'll see. So JavaScript plus WebAssembly. So that's the idea in general. So today just the logic. And I do plan to do a regular stream after, let's say, hour and a half, maybe 2 tops, of coding this N in line. So if I finish in 2 hours, it will be perfect. Anyways, I will stream the regular day 26 of the coding challenge. Hello, Andre, how are you? You can hide from making native cells. Yeah, I'm trying. I'm doing my best, but I'm out of options, running out of options. Okay, so let's start. I will try to use all these things that Robert did. So for some of you guys, if you don't know, Robert is a regular guy here, like Andre. Andre is also a regular here on these streams live. And this is the code that Robert wrote to showcase what can be done in Zig, some additional features. And I did go through this code 2 days ago, I think. So there is a video on the channel in the tic-tac-toe play. Sorry, not play, the playlist, I wanted to say. And I'm going to now try to use as much as I can, but I will make it a bit different. So what I mean by different, so this is the Robert's version of tic-tac-toe and my version of tic-tac-toe. They were using arrays, which were one-dimensional arrays. So a bunch of, let's say here, if let me just make this a bit larger. So we had something like the characters here stored, of course, with quotes, which were representing where in the field in tic-tac-toe something is stored, like X or O, and it was one-dimensional array. So we used the index to take a specific element, and then we just printed. So we printed these first 3 characters in the first row, then new line, then in the next row we printed the next 3, and so on. So that was fine for tic-tac-toe, but I want to practice. I mean, I can do it also here, the n line. I could do it in the same way, but the point is I want to practice new things that I haven't done so far, and I haven't done multi-dimensional arrays yet in Zig, so that's why I would like to give them a try today. So I will write this game in different ways. So instead of having one huge array where I will store all the pieces and then break the line and just print like that, I will create, so let's say I will just represent like this. So imagine this is like a big array, and then it will have a smaller one here, and then this is just visual, of course. So let's say if it were tic-tac-toe 3 by 3, then you would have here maybe X as the first element, then maybe O's as the second, and so on. So all these fields would be represented this way, but this time as a multi-dimensional array instead of one-dimensional array like before. And of course, because this game usually is called 4 in a line or Connect 4, and it has specific dimensions, but it's always 4 in a line. So I'm going to make it more dynamic. So I'm going to make code run, no matter if you have 10, 12, 15 rows and columns or whatever combination you want to have. And you could also select this at the beginning. So at the beginning, now I'm going to hard code this, let's say the size M, N, or however we call it, and this number that will represent how many pieces in a row are considered to be a winning situation. But then maybe next time I will add this dynamic. So once I have interaction with the operating system, sorry, with the file system, once I install natively, finally, Zig on my machine, then I will play with writing with files and also maybe taking the user input from the keyboard and so on. So that's the idea. So that's in general what I want to do today. So let's start. I will do the same things here like before. So this is the number of rows, number of columns, and tuvin. And let's make this a bit larger so that it has a standard size. I believe it's 7 columns and 6 rows. So let's start with that, and let's say 4 for the size, just to have this one. And then of course I will test it for different sizes. So here rows I said 6, columns 7, and tuvin 4, so that we have a standard one. So this is the first thing I'm going to do. Then this is what we used before for the moves. I can do the same, and I will. So this is just explaining telling to Zig how this game will play, right? So this is the first move of the X player. This is the first move. So the index marks the position in the board. So like here, this is index 0, this is index 1, this is index 2, this is index 3, 4, 5. Of course, it was one-dimensional array, but the same concept, the same indices. I mean the same like I'm writing now, not what I'm going to do today. So this is how it used to work. So I'm going to do something similar, but because now it's going to be two-dimensional, I cannot say I want to play here. But actually I can, because there is a gravity concept. So I cannot say, for example, I will play here, because it cannot levitate in the air. So if I say just like column 1, then it will fall all the way down. So yes, then I need just like the number of columns, that many times, that many options to play with. And I can then technically use the same approach. So I will copy then these two lines as well. This is just to use some symbol to represent visually, because we print things, so that we have some visual representation. So I will keep the same things like in this version here, because that's not going to be the focus of what I'm going to do today. And these moves, I will change them. So these are just like, this is a placeholder. It's not going to be larger than the number of columns, right? So the number of the column will determine the maximum number that can be here. So 14 cannot be if I have 7 columns, but I will just leave it as it is for now, and then change that in the future. Then what else here? Board size. Do we need the board size now if it's two-dimensional array? Let me see what we did before. Actually, I don't need to see, but we can, maybe, yeah, this will be different because now it's two-dimensional array. It's going to be. So then I will not do this now. And then this is like the very interesting part that Robert did last time. So I will try to also do as much as I can comp time validation, so that we, just for practice, of course, so we don't need to do this in the real world. Hi, Robert. Good evening. How are you? I'm reusing your code, sorry. So I'm going to adapt it for this game. So just to practice things. So here, let's see the first check. If rows equals 0, I can be. So I will even change it a bit. So let's say that it can be lesser than 2 win, because I want it to be possible, so that you can do vertical win. So then I will say if rows is less than 4, just to play a bit, rows can be lesser than, and then we can inject here, not this, but this. And I forgot the tuple. Where is my dot? Which is the, yeah, it's English keyboard. I just made a mistake. So we want to say 2 in here. That's the idea. Then columns, again, I will set it to the same, just to, so then, yeah, not 4, but 2 in. I want to say 2 in. And here the same. It's just hard-coded now as 4, but I want it to be dynamic. So if col is lesser than 2 win, then we have the same, can be lesser than, and let's copy paste this like here. Okay, if 2 win equals, so let's see, maybe I will limit it to be at least 2 pieces. So if you put 1, it does make sense, right, that you have a winner immediately when you start the game. So you have to match at least 2, maybe even 3, but let's say 2. So I will say here, if this is, so I will hard code it lesser than 2, then can't be lesser than 2, just a quick fix. Then let's see this one, and do I need it? If row is lesser to win. So then, because I have hard coded this here, then I technically don't need this one, it's redundant. Then symbols len, what is the symbols? This is okay. So this is just to make sure that we have one character that will represent player 1, one character for player 2, and one character to represent the empty field. So it has to be 3. It does make sense that it's not. So I will keep this as it is. And this is also check. So I remember this from the previous, but I will just go through it quickly for the ones that haven't seen the previous video, where I had this, where Robert did this for tic-tac-toe. So this is basically checking here that all these characters are different, so that you don't have any 2 that are the same. So and of course not 3 same characters, so that we don't have X for the player 1 and X for the player 2, for example, or O for the player 2 and O for the empty characters. So that's what this does. It checks that they are all different between themselves. Then let's see the moves. Okay, so moves is this part. So I will come back to this. I will comment it out for now because, like I said, I think I'm going to use moves. I can use it even in the same way because I just have to select the columns. But I will think. Maybe I will complicate it just to practice things. So I don't need to. They can be integers. But maybe I will make them something else. Maybe, I don't know, a tuples or something. I don't know. Just for fun and for practicing. So we'll see. So that's why I'll comment this out. And then let's see what this does. It goes through all of the moves. So I will then comment this for now out because it depends on moves. Okay, so then let's see the board. Now this is going to be different. I'm going to make a multi-dimensional array. So it will be the array which will have this many. Okay, in this case it's 4, but in my case it's 6. So number of the rows times the number of the columns. So rows will be the second dimension, right? And the columns will be the first, the opposite, sorry. I want to say rows will be the first square brackets. That's what I meant. So that you first select the row and then the column. Okay, so let's see here. In this case, the board was a single dimensional array, which took the board size. Now I'm going to make it 2-dimensional. So I will try to do this without looking at the docs because I forgot how the syntax, how you create the multi-dimensional array. So I will create it from memory, and then if I struggle, then I will go to the docs to see how it's done. So I will try first just to take the number of the rows here, and then can I just do it like this? This is the own type. Okay, let's see just if I can do the calls here. How they were called calls. Yeah. And I will just to test this because I have a lot of these things that could potentially. Let's try to compile. So it will, because I don't use these things, it will complain. But I just wanted to see if it will tell me something about 11. Found 2 where? Compile error. Okay. To win. So I cannot do this in compile error. I cannot format a string like this. So I have to call the function to format it, I believe. Okay, so I will just hardcode it, just not to waste time. Now I will come back to this. It's interesting. So I would like to also play with this. But for now, I'm just going to do a quick fix because I want to play with the board now. So I will say lesser than to win. Just hardcode it. So here I will hardcode it. So I will not have this one, so that I don't have to play with formatter now. And the same thing here. So this one I delete and I take to win actually here, and then delete the rest of it and comment out this part here. Let's see now if it will complain about something else. No, it doesn't. Okay. So this passed actually the Okay, nice. So it looks like I can, but I really forgot how to make multi-dimensional array, but it looks like this is okay. Hello Dev, how are you? Okay, this is fine for now. Then let's see, this is for checking the winner. I'll make that later, so I will have to think now what I will do first. First, I would like to make a board. So let me see where the board was created. Here was here, I believe. Yes. So this is how the board was created this time. So let me do that first in the main loop, but I will have to adapt, of course, because now we have. So let's just change this one into game starts here, and then let's make this an empty tuple, and let's see what the board does here. And I will just let me print it that I'll have to also mutate so that it doesn't complain because it's variable. Actually, I will try to print just to remember if I have to when it's a reference to. It's not an integer type, so I forgot if I have to, but I think I do. But just to play and crash maybe the code, but it's fine. I'll fix it. So let's say board, and then I will do \n here, and then try to print the board as, let's let it be any for now, just to try. And then here I'll have the board. So I want to see if it's going to break because I don't mutate. And I want to now, of course, change the board so that it's multi-dimensional array. So let's see what this does. This creates symbols 2, which is the empty character. So this part is okay. U8 array 1, and then it multiplies by the board size. So I can technically use this and multiply by the column size, right? So that I have one array, one row. So I can say here the calls, I believe I called it. Yeah, here it's calls. Then once I have this, I can maybe multiply again by the number of rows, so that, and I don't know, because I multiply, if I multiply the array in this way, and how can I do this syntactically? Let me see. So how could I tell it? So because this is now one array, this entire thing. So in a similar way, if I were to copy this and I say one of these guys, but multiply, so let me try. But I have to be careful not to break. So I will copy down just as a reference so that I can see how it used to look like, because I'm going to change it. So if I say here 1, and then I have to say what is the type, and the type is the array. How can I say it's a type array? I forgot what was the shortcut. Let's say if I just leave it as it is here, and then I do here star star, so probably not going to work, but just to try and see what will be the error. Yeah, of course. Print. How come? Not what I was expecting. Okay. Yeah, because I didn't import it in this way. So let's do that in this way. And let's go to print. This is because I refreshed the page. Now let's try this one. Now we get the real error. Populates board with empty symbol. Local variable is now mutated. Aha, so this is the different thing. So let's do dump it first, so that I focus on the other error. So this one is going to be called the, where is my reference here? Reference of board. Come on. And let's run it now. So this, at least this error shouldn't appear anymore, that it's never mutated. Okay, now expected type found com time integer rows calls 8. So where is this? In 37. Why I have 8 here? What did I do here? Ah, U8. So somehow I deleted by accident. Now, what does it say? Expected type 1, U8 found U8 in 41. Now we are finally here at this level. So this is, of course, because you cannot do that in this way. So let me think, how can I do that? Hello, Otto, welcome. Inboard says 8 instead of... Yeah, I deleted by accident. I don't know how I did it. But let me see now. This is what I don't remember how to do this in dynamical way. So I don't want to do it like providing statically something. So let's go step by step. So this is going to create one array. In this case, 7. I think, yes, 7 is the number of the columns. So this part creates one array of U8s with size 7 that has underscores, in this case, characters that are underscores. So this part is okay. Then how can I make this repeat? So this thing, if I multiply here, theoretically that is what I want. But how can I have here this in the... Let me try to read the error and if I can understand from the error. So type 1 U8 found... error expected type 1 U8 found U8. Maybe the parentheses things or something like the priority of operators. Then varboard 1 symbols 2. Okay, populates board with empty symbol. Okay, that's from here. Should be populating it. Okay, so maybe this is a chain reaction. Then it's misleading a bit. Because for sure I know this worked for a single dimensional array. So how can I say the type is this? Can I do it like this? Now I'm just like brainstorming, complete nonsense, but just to see what error I will get now. After, so here the U8, which one? The second one here, it expected comma. Because now it thinks this is the starting of an array and that this is the first element inside. So I can do something with curly braces because I have here, I think this is the original version that I had with the original error. So like here after the type we have curly braces. Then maybe I can just say this is the type and then multiply like this. So now it's different. So expected type expression found curly brace here, the first one. So it doesn't like the first one. So I have to specify the type, I believe, here. So now let's try to do, how can I say the type U8? Let's try like this. So this is the part that I forgot how to specify that the type is an array. So if I do this, will this work? Or just if I do without curly braces because I don't want to initialize anything? Unable to infer array size. So if I just say the size, is, so now I want the number of rows, right? So I want, no, the calls, because that will be the size of the inner. So let's try calls. Oh, this is like the happiest moment that I've had in the last month or so. Nice, nice, nice. Yeah, it looks so intimidating, like when you just look at this, but if you think about it, it's logical. Yeah, this is why I wanted to practice and to use multidimensional arrays. So now they are, let me check. So we have one board which has one, two, it's going to be hard to count because of the slider. So this is the third, right? 1, 2, 3, 4, 5, 6. Yeah, 6 rows, and every row is 7 columns. So this is the ordinary number of the underscore in Unicode. So because the underscore here is the empty one, so that's why this is 95. Okay, and let me just check, sanity check. If I wanted to print one element of this array, can I do the regular 2 square brackets pairs to print? So let's say something like element equals, and then here if I can inject and I say, for an example, what I want, board is called board, and 2 pairs of square brackets, and let's say 0, doesn't matter which one because they're all 95s, just to see if this is going to give me 95. Yeah, no, because it's on the end maybe. Yeah, because I didn't do here \n, so it is fine. It is, at least this part is easy to read. This is like pretty standard syntax in any programming language, but this is Zig specific. I mean, in this way, of course, I could have declared this in a bit different way. That would probably be easier, but I wanted to do it in this way just to test. Let me see what you guys wrote. Hi, Caro, how are you? No, it doesn't. I was doing this a chessboard using U8 arrays in Zig or in other language. Yeah, arrays are always fun. Okay, so now I have the board. Let me see what can I do next. I can create something what we had here, the drawBoard function. In this case, it's going to be completely different because it's multidimensional, but I will just copy paste it as a reference here. And let's see how this one is designed. So I can still take a pointer to the constant board, and I can paste it here. So not paste, but call the function with the board as the argument. So it's called drawBoard. So let's just call it here and pass the, I believe, the address of, if I'm not mistaken, we'll check. So I'm trying not to look at the original code. And then here I just want to print something. So let's do a board in this way. So this is enough. So this is just to have, I'm not even printing the board. This is just the word board printed out, just to understand that I have something printed out, that this call of the function works like small steps. What does it say? Unused function parameter. Yeah, of course. So let's just do then here something like this. And I will not use any this time. I'll just do this. What do you say? Cannot format array without string or any. So let's say S. What it will be if I say S? So it will break because no, it will not. Okay, nice. Yeah. Oh, yeah. So it's, this is the default formatter. Okay. Yeah, it shows the board in a weird way, but still it's a board, and this proved that this function call works fine. So now instead of this, I can actually print it just for a visual helper as for now, and then I will do something similar like here. So we want board. Now I will try to generate two things here. So I will try. I don't know if it's possible, but I want to try that as well. So what I mean, here this was generating one number because we had the one-dimensional array, but now I have two-dimensional array, so I need to generate two numbers. So I will change also the name. So I will say R for row and C for column here, and I will try to generate two things here. So one again here, and then what I will do here, let's see, what is this ending? I forgot what this did. There is U8 type. This ending is U8, and then we have if one modulus calls equals 0, then this is just to make a new line. Okay. So in this case, I will do not modulus calls because we don't have this large number that is the index. So let me explain for the ones that are maybe not following. So in the previous version, like I said, we had one huge array, so you can think of it like this. And in this version, we have like this. So in the first version, this was the representation of the indices of this tic-tac-toe. Sorry, that this is not aligned, should be. So then 6, 7, 8. And that's why we did this. That's why Robert did this, because once you reach, so Robert was actually generating numbers 1, 2, and 3, not 0, 1, and 2, because the code started with 1 in this section. So the for loop starts generating numbers from 1, not from 0. And then when it's 3 or 6 or 9, because when you do modulus 3, it will be 0, which is exactly the sign that you're at the end of the row, because we didn't have any other information from the single dimensional array where is the end. So we just had the number of the columns, and then this is the way to calculate where it should break line. But in this case, it's different because I have now two-dimensional array, and I know the number of the columns. So I can just literally say, if the C equals number of columns, print the next line. So it's a bit easier in this case, because, I mean easier, because you don't have to use modulus. So here we say the ending is going to be equal to C. So if C equals calls, then \n, so then we want the ending to be a new line, else space, because we want to print, you see how it's ugly here. So because I'm not printing anything between two characters, so it's 9 characters next to each other glued. So that's why this is going to be better. So now this is going to generate, yeah, then I don't need the call. So I thought the code was doing, I forgot what the code was doing. So I don't need this R and C, I just need 1. So I just need the columns like this. And then I do the same thing here, and then I print C. This is just the formatting. So the tile is the thing that comes out. The board is now different. Yeah, so the tile will be complex, not the... So this C part is the same, the ending is the same, but this tile, if you loop through the board only once, you're getting an array, not the entire array, not only one tile, not only one character. So I will need to do one more for loop here, for example, not necessarily the only solution, but I can do that, for example. So then I will say I want to loop through the board, but then this is actually going to be one row. So I will change the name of this to row. So I will call it, I already use row. So I will call it R, for example, just short for row, so that I generate a row, that I take one row per cycle here. And then I can do another for loop here on this level. And let me think. So I do want to do this for every row. So then I maybe even don't need this one because I know where the row ends. But let's just for fun, let's do it in this way. So now I will have the R that I want to loop through. And I will again do this until the end. And I will create a different capture group here. So what I need here is, now how will I call it here? A tile. Yes, because it's already used here as a tile. So it makes sense that I call it a tile. Let me see what you guys wrote. Robert says chess is possible. This is the response to Icaro. Chess is possible to do with bit operations in 64-bit numbers. That's interesting approach. And then Robert says it's really cool what you can do. Yeah, Zig is cool. So let me think what's happening here now. So I want to have the for loop here for sure. And I want to do this inside of that for loop, which means I will start this loop and end it here. So let me see that I indent a bit. And let me just think for a second again. So I'm looping first through the board and generating numbers from 1. So the board will produce 1 row per loop in this case, which I then capture in this capture group as R. And this will produce numbers from 1 to, in this case, 7, because I set number of columns to 7. So that will be here. C will come here. Then in the nested loop, I want to loop through this R, which is a row, which is an array. And I actually don't need to generate these, right? No, actually here I need to generate the number of columns. Because after, I don't need this, I can print after, but just to play like with the logic, I will do that. So then I don't need to generate columns here. I will just leave R here, and here I will generate tile and columns. So now, if C equals number of columns, yeah, this makes sense. Otherwise, I print. Okay. So I hope this works, and let me comment out this older version. This is just for reference. If I mess up, that I don't have to copy from before. Let's see what we have. Nice, nice. So it works. And the entire board is printed. So 7 columns and I guess 6 rows. I'll try to, where is the scroll part here? Why I cannot select it? Something is off with, let me zoom out at least. So yes, it's 6 rows. Okay. Nice. So this works. So then I will just delete this part. We don't need it anymore. So the draw board function works with multidimensional array now. Okay, so let me think what can be the next step. So let's go here in the mail and just refresh the memory what I did after. So what Robert, this is Robert version, what Robert did after the creation, after printing the board. So there is this for loop, which is, as I can see, the main game loop. And then there is this calculation who is playing. This is pretty much the same. So I can reuse, and that's not something that is so hard. So I can copy paste. And I will do then the last move as well here. Where is the last move used here? So actually let's do step by step. So let's do a for loop first. After the board is drawn, let's do this first. And it ends, let me just be careful here. So I will copy actually, just not to make a mistake, everything, and then I will delete. It's easier. So in the main function here, if I do this, and I want to delete now everything, and I will come back to it. So here, draw board, I want on every turn. I will just leave that, and then I will delete all these things. Maybe I will leave this one only. So let me see what happens here. For Aha, this is why we need board size for game loops, because it's maximum, in this case, 7 times 6. That's how many turns are possible in total. So then I will use the board size where it was. Yeah, I will copy paste it from here just to save some time. So this part is useful in the new version as well. So now we can go back down. So the for loop generates maximum this many cycles. Starts by saying the first one is 0 and the last one will be the size -1, right? There is this turn as a capture group. So then inside of the for, first thing is the current player constant creation, and it takes the symbols. So those 3 x, y, z that are stored as symbols as this variable or constant. Then turn modulus 2 will basically give you so because you're doing modulus 2, it will never be 2, right? It can be only 0 or 1 when you do any number modulus 2. So it will never select this, the index of this one. So if it's modulus, if you say 2 modulus 2, the remainder will be 0, and that will be the index of x, which is correct. So in the 0th turn, and the 2nd and the 4th and so on, it should be x, otherwise O. So this is correct. We don't have to change anything. And then the print says turn, and then the number of the turn here, and the player, and this is this player symbol, so I will not change. This is perfect. And of course here, because it's a human number, you want to say first turn, you don't want to say 0th. That's why +1 and current player. So now this should work, and this should just like draw board 42 times. Okay. Yeah, so this is writing 40. I will trust that it's 42 times. And by the way, I don't need this anymore, and I don't need, yeah, this one I will leave. So this part here, I don't need anymore. I will keep it as without. Okay. So then let's see the next thing that could be interesting to do now. Where is the main loop? Here. So this is what we have. Now the last move equals, so this is just to take the moves from, so now I have to think how I want the moves to look like. Should I use, so maybe I can leave moves as integers, but I would like to create additional array that would be maybe array of, let's say, structs or something like that. So what I want to do for the future, I'm not going to use it today, so I don't need it for today, but I would like to have, for example, the history of moves, so that maybe we can implement undo in the future when I do the UI or something. Even before the UI, it can be interesting. So for that, I will need the history. So I can create something like an array that I will call history, and it can. So we don't need it because because of the gravity thing. So I really can just use the moves. And I can say, okay, this is the last move, the index of the last move, like it's here, it's created in this way now. But it would just for fun. So I can say that the move will consist of the struct, which will say what is the player, so X or O in this case, or whatever the symbol will be, and where the player moved. So this is something that we can say. And I just for fun, I will maybe integrate also the turn number, so that we can easily maybe in the future say, I mean, you don't have to, you can also do this with the index of an array, but that we just like practice also extracting data from the array of structs, so that I can say like, give me, represent the moves from the 3rd till the 8th move, for example, something like that, so that we can play. So let me make that one. So I want to create now array of structs, which will be a history, and it will start as an empty array. So let me try to do that, because I've never done array of structs before. So let's first create a struct. So I can make it a constant. So I will call it like, so it will be a history event, or how can I call it? History. Let's just call it a move. It doesn't have to have the name history. So it will be a struct, and then let me see, it will have what I said that I want to have. So first of all, I set the player. So this is the first thing, and this can be, so it's going to be a string literal here, which basically doesn't exist as a type. So it can be character, because it can be a single character, so that I also play with the conversion. So let's say a character. Yeah, but character is also just a literal, so there is no a character type. So it's just like U8 then. U8 that I will treat as a character. So then here, and I will write a note to myself if I forget, because I'm not going to finish all this today. So I will just say, so the idea is that we have this or this, for example. Then put it comma here, and here it's comma, yeah, because it's struct, not expression. So then what I said, the next will be the column number. So I will just call it column. So this can be also U8. So this will represent where the player moved. Maybe I will even complicate it more in the future. Not that we need, like, again, but just to play nested struct. So maybe I will change this in the future, that it's like X and Y coordinates, something like that. But for now, let it be, because I want to focus on different things. And what I said, the third thing will be the turn number. So let's say turn. And this is also going to be U8. This is the struct, and then I will create the history. So I want to make a history, which will be, let it be dynamic. So let me make this also, can this be dynamic size? Yeah, it can be the size of moves, because even if the moves are not legit, this history cannot have more entries than this, so it can be at the most that large. Maybe I will also change it in the future that I can resize arrays. I also never played with this in Zig, but for now, just like to start with something. Let's say that this is going to be the, can I say moves len? I forgot if this is going to be working, because this is fixed size here, known at compile, so I should be able to do this. And I forgot if it's .len or length or how it's called. Let's try like this, and it will break the code if I don't succeed. And I need also the type will be move here. Right, let's see if I can do this. I've never tried. Let's see. And then let's just dump it for now, if it works, so that we don't have a problem. It's not con, sorry. History. Let's run. What is the error? Where 14 here. Where, which line? 17. Why? Wait, don't use var or constant declare variable. And why it says it's a field? It thinks it's a field. What did I do wrong? So history here. Why thinks it's a field? Where it's confusing. What did I do wrong? So it says expected comma after field history. Why? Okay, I will just comment it out for now. This is going to break because I'm not using the const, but I just want to see if it's going to break first here or something. Const move struct variables must be initialized. So this is the first problem. And why it says variables? I'm never initializing this one. Yeah, because here I say it's an empty one. Yeah, this is because I never tried to do this before. What did I do? Wait. Where is my const? Move. Wait, am I doing the definition of structs wrong? I forgot the syntax. Give me just a second to double check if that's the problem. Where is the struct? Here. Equals, so it's not the columns. Okay. Yeah. The syntax was wrong. So here I need an equal sign, not... Or, yeah, it makes sense now. I'm making an anonymous struct on the right, and then I assign it to this variable. Okay, now this works. Now let's see if this is going to do the same thing. Maybe the first thing was influencing the second. Maybe I'm wrong. No, it's still the same thing. Expected this. Okay, but it actually does complain when I do this, so it's okay. I don't need to dump it anyways. But just for the sake of sanity, I want to double check here in docs how it was dumping the consts. So let's just search here underscore equals. This is for the variable. I just want to see for the const. I forgot. They're dumping here the return of printf. Where is the const? Does nothing. So it's the same, but for some reason mine doesn't work. So I'm missing something. Because here they initialized it to empty and I don't, probably because of that. So I'm just declaring the type here. Okay, let it be for now as it is. And let's see what I want to do next. So I have the history. So let's try to add something. Let's actually try to print the history, how it looks like now. So I want to do that, and I will for now comment out the draw board here because I don't want to do that 42 times. And I'll just print here the history. I just wonder how it looks like now. How it looks. Wait, this is before the turns. So it just says it's 14. The size is 14 because I said it's going to be equal to the length of this one, and this one then obviously has 14. 1 2 3 4 5 6 7 10 11 12, yeah, 13 14. So let me try to loop through it and just print what is there and if it will break the code. So where is my print? Here. So let's do the for thing again, and let's print it from here. It's easier. A copy, not print. So this one here, and let's do before the for. So here, so let's say for, and I will go through the history, and this, I don't even need these, so I can just say something like move here, and then I can just print the move, try to print it, so just to see what will happen, because it says the size is 14, but there is nothing there. That's why I'm curious. And then let's just print here the move like this. And probably should have. Notice you cannot count index from arbitrary value. What does it say? Error type is not indexable and not a range. So I have a type there inside. Okay, so then I must have defined this in a wrong way because I cannot iterate through it. So if I do this and then just say 14 times, this is just for test, of course, I'm not going to do this really at the end. And let's do, because I didn't specify, no, I did specify the type, yeah. So I cannot do this. I have to make 14 of these guys. Okay, I don't want to do that. Let me try something else instead, just to see if it will work. So instead of looping, I don't want to do that yet, so I will test that later, because at this stage this will not work. Where it was history here, so I will comment out this part here. And what I want to do instead, I want to say history square bracket just to test. I think this is going to break 0 again, and print it just actually, so I can do that here. I want to test two things. First, this one. And then this is going to break, I believe, but just to test. Yeah, so it says type does not support indexing. So this here is just a type. It doesn't contain anything. This is something that I'm missing. So I thought that I'm going to say here, where it was here. So I thought that I'm going to define an array of this size, which is by default initialized with, yeah, the question is like what would be then initialized with, but it does not. This is just a pointer then, if I'm not mistaken, to an, so it's not doesn't contain any data inside. So what I need to do instead, I want to probably do something similar to where it was here, not here. Where is the board? This, so not this, but something like this, that I take. So actually it's better to copy it from here. Where is the board? Here. So I want to do this maybe, but yeah, so the problem is I can easily do this so that it contains 14 elements. So I can do that for the first test, but I would actually like to make this dynamic so that I play finally with dynamic size. Then it cannot become time. But let's see, first things first. So let's try to do something like this. Instead of making a history, how it is made here, that I do something like this. That I say the history will be of the type of move. And I will call it history. And let's say it's going to be size 1. And then here I have to create a dummy struct like this and multiply it by, so because this is dynamically calculated, I don't have to specify any size, so I can just do once. For example, let's do, let's say just multiply by 2, and I will try to do it down there in the, and I will call it history 2 just to play with, because I have history, and then I have to comment out this part here. So I create another history 2, let's call it history or history test. then it's move, this is fine, and then instead of symbols square bracket 0, I will make one struct. So I will say dot. So I think this is enough for Zig to understand, and I will copy from the struct these things, and I will adapt. It's easier just to see what is there because I already forgot. So then the player, I will just make this, let's say, and I will also want to test if this is going to be coerced. If I make it, for example, X, then the next thing here is, and I also want to see, because I forgot, if I have to say the name of the field equals the value or it will be inferred. So let's test all these things. So this is the column number. So let's say 1, doesn't matter. And then the turn, and let's say 2. So just let's see if this is going to pass. And then because it's a variable, I will have to do let's say here the dumping of the reference. Where is the reference symbol of the history test? Here. And then I want to actually print it and see it. So I can copy paste this part here. History test. Here, okay. Let's see if this is going to work. So a lot of ifs in my mind here. And of course, one of them, okay, because wait, 16, expected 14, found 0. What did I do? I probably changed and I forgot that I changed. Okay. Yes, I changed this. Okay, now it's, see what they say. Oh, this is some interesting error, not what I expected to see, but a different error. So I expected an error, but not this one. U8 does not support array initialization syntax. Move. Why it's, this is the copy paste problem. Copy pasta. Of course, it's not U8, it's move. And then the type is not this one. So history test. Yeah, because copy paste problem. Okay. Now, what did it say? Syntax. So let's try what it used to be. So U8, U8, right? So the field names were player, colon, and term. Let's try to do that. So let's try to say, so I'm trying to do all these things without looking into docs, and then of course if I get stuck too long, then I will take a look in the docs. I'm just trying to remember things before I do that. So this was the colon, right? This is how I called it, and then the turn, I believe, is the third one. So let's see if this is going to fix that problem. What is it? Now it's different one. So expected. So obviously you cannot do this. So let's try with equal sign, just to see. I completely forgot the syntax for these things when you play with structs, how you do it in Zig. And I don't know if it's this possible at all. Comma. Yeah, so you cannot do this in this way for sure. And then if I do a move here and then initialize in this way, so this is the same problem. Now let's try the previous. And this is, okay. Yeah, this will not work. So let me just take a look in docs. I don't want to spend too much time because I'm already like 1.5 hours into into the stream, and I want to do as much as possible. Let's see how they did these things with struct. So this is one example of a struct. And this is, dot, yeah, dot notation equals, I forgot. So let's try with the dot notation. So let's do that in anonymous way here. So without the initializer function. So let's say dot player equals dot column equals, and that dot turn. Let's see if this will work. Okay, didn't break. That's a good thing. Yeah, it even did repeat, so nice. This is the way. And would it infer the type? Because I said the type of the array is move. So if I just do the dot here, would it infer the type? Yeah, perfect. Yeah, the same result. Okay. This is at least a progress. And now I forgot. Can I make this array increase the size? So what if I want, there is a push method, right? If I'm not mistaken. Let's try. So let's do this history test. Dot push. Like, kinda think it's a push. Let's see. And let's do the similar thing here. Anonymous struct, which is then, let's say, O this time. Column 2, just to have something different that we can see if it works. No, what did it say? No field or member name push. Yeah, so let's see in the docs. What they do they have something similar? Okay, this is like in the nodes they are making a list, a linked list. Default field values, multi-default field values, external struct. No, I want arrays, sorry, what I'm looking, not structs. Arrays, I wanted to look if the array can be wait, just to see some integers are here. They set it to undefined. So this is a fixed size. Then modify an array. They take the reference, the address of some integers. They generate these numbers. Then they take whatever comes here, which is the element of an array. They dereference it. And then they have one. This is not actually dereferencing, this is the pointer, sorry. So they take it as a pointer. Then they use dot star notation to assign the new value. So this is possible with a fixed size. Let's see. I mean, fixed size also works for me because I actually have the fixed size of moves, but I just like wanted to refresh my memory if I can dynamically resize the array. I'll just read here. I'm not going to use a lot of time to do this. Yeah, doesn't say. So let's do the fixed size. So I want to do what they did here, similar what they did here. So I want to set it to undefined. Let's see if this is going to work when I have a different type. So this is i32 and I use different type, the structs, specifically the move structs. So I want to do something like this equals undefined. Because of the size. Okay. So let's see. If I say equals undefined to this one, let's see first if this is going to run, if it's not going to break. Small steps. And it does. Let's see what is different. Because this is variable. That's why. So I have to probably make it variable. It's the, sorry, 2 times equal. Okay, so let's try first, leave it as a const just to see what will happen. If this will pass. Okay, this is different. So that now this passed. So this push, that was previous attempt of playing with arrays, like they're in Python or in JavaScript or something. But that doesn't work obviously here. So this one, I will just delete. I don't need it because it's the wrong code completely. In JavaScript, there is push. In Python, it's append. So this seems to be working. Okay. So now let's do. So this is a const. Let's now try to do what they did here. And let's loop in a similar way. So this part is interesting. And let's try if this is feasible at all. That's the first test I want to make to see if this is going to work at all. So here, this is the history. And before, why I got for the history the same thing. And for the history test, when I print the history here, why is the same thing? Play, move, play, move, play, move, play, move. What happened now? What happened with my history? Because of the undefined. Oh, this is so cool. It actually initialized everything. Oh, this is so cool. Wait, is it possible? This is so cool. If I don't do this, then it's not, it doesn't contain this empty struct, not the empty, but structs with everything 0. Where? Yeah, of course, because now it has to be initialized because of what was before. I forgot how it was before when this didn't break the code, but it was not initializing things. I will look at the video afterwards. But this is so cool that you just say undefined and then it will populate with the empty moves basically. I mean, not empty, but the moves that are all zeros, all fields set to their default values. Okay. Then I'm just thinking, so is it actually possible to resize the arrays in Zig? I forgot completely about that, if there was some example like that. But anyways, this is good for now. So I will leave it as it is because it's almost like 1.5 hours, right? So yeah, let's try to do more things. So let me see, guys, what you guys wrote. You can't rely on it being zeros. You can set all to zeros, like so. Splat. Yes, splat. I forgot about the splat. Okay. And you cannot rely because they can take some part of the memory that was used before or something like that. Is this the reason why you cannot rely that they're all zeros? And let me see. So I will fix that for sure. I just wanted to see what I want to do next when I have the array. Then we can take here the turn, the index of a turn, which is already generated here. And let's for starters just change the turn inside of these, inside of the history, that the turn will be 1, 2, 3, 4, and so on. So in each struct that it will actually reflect the real situation. That's the next thing I want. Robert says, or with memset. Memset also works. Yeah. Thank you. So is the reason why you cannot depend them that they rely on that they will be zeros is what I said, because there might be something there before, might have been something there before, and then when you just like the reference, it's still there, it's not set to zeros or something. So when you technically allocate the new memory, it can take this memory that is already something is there, so it's not set to zero. Define and not defined to be zero. Aha, okay. Just thinking out loud. Okay. So what I wanted to do, yeah, let's do first what you suggested. Can I copy from here? Yes, it looks like can. The split. Okay, let's try to do that. Andre says it will probably be 0 for global variables and rely on the really undefined for local variables. What did they do? 2 of these probably. Yeah, perfect. Perfect, thanks. Oops, this went wrong. Yeah. And it's so interesting that you cannot do this, that it will break, that it doesn't allow empty expression. Nice. Okay, so I will leave for the reference the previous version, just that I remember that I had it. So I will use this one, but I will just leave this as a reference and to remember that this shouldn't be done like what they did in this case in the docs. So here, where is the for loop that I pasted? This or no, it's not this one. I thought I copied this loop, some integers. Maybe I didn't paste. Yeah, I didn't paste. It looks like I didn't paste. Okay. So let me just double check. So it's some integers. Item star. Yeah, I definitely didn't paste this. Yeah, it's different. So okay. I thought I did, so I didn't. Where I have the turn is, where is the main loop? Here. So here I have the turn. So I would like to then use this loop to inject the number of the turn into, so actually I don't need a for loop because I already have the for loop for this. So I can just say, in my case, it's called history, right? So history. And I want to say square brackets in this case. And the turn is correct because turn is 0, starting with 0. So this will take me the first struct, get me the first struct. And then if I say dot on that struct, let's say turn here. It's because I think I also call it turn, right? yeah, I can see here turn. So dot turn, let's see if this is going to work. So I will delete this part, I will delete this part, and then I want this to be set to a turn. So what is the turn? The type of turn here? This is comp time int, right? So let's see what will happen. It should be able to infer. Let's do this like here. And then I will try to play with it if it doesn't work. What did it say? Expected expression found equals. What am I doing wrong? So this is supposed to give me a struct. Let's print this. Just go step by step. So let's just print here. I will copy actually here one of these prints. Actually, let's do this one. This one is simpler. So let's say something like this. And here I will do this. And let's try without anything and see if it will work. Yeah, okay, this is a struct. So if this is a struct, why I cannot directly use the field? I forgot how to access the field of the struct. Let me see, not to waste any more time. Where are the structs? Dot, where is the dot here? V1 is vector3 is xyz. Okay. Point y. This is to setting it. Maybe because I'm setting it, I have to use the address of. Let's try. That will be here. So I believe here, because it should happen, this should happen first. Then, yeah, but I don't use this as, so let's try like this. Just to see if this is going to work. No. Doesn't work. So let's go to the docs one more time and see how they do. Just return, blah, 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 how they set things on struct. This is just like the access where they set some values, where they change them. So this is the only time I see them set. Let's see what they do. So they take the address of point.x, paste it, put it in the as an argument to this function, which is the pointer, and then they say they just read it here, and the second one is 09, so this becomes y, and then they just dereference the base pointer, how they call it, point field parent pointer. So this is how they take. Okay, so maybe I can use the same method once I have the but actually I want the opposite. So I want the field from the base pointer kind of want the opposite, because here when I print, I have them. Let's delete first of all this thing. I'll put it back in the previous error like this. So here I print history turn. Okay. Let's run one more time this version. Yeah, so I'm getting the struct. Why I cannot do this? Why I can just say dot turn. I can. Aha, so the assignment is the problem. Okay. So this is my struct. And this is the field inside of it. Reading the field. But then if I wanted to change it, can I do the dot star here? Let's try that. Dot star. So this is the field dot star. Let's try like that. I forgot these things. It's like I did this like 1 year ago. Yeah, because I didn't practice. Cannot dereference non-pointer type U8. So because this is not a pointer, I cannot dereference it. Can I just say, I can try this simple thing. Cannot assign to constant. This is a constant by default. Okay, so then I believe if I change here how it was, do I just say var here? Yeah, I kind of like flashes back into my mind that I kind of remember that, maybe I'm wrong, but that the fields are by default constant. What does it say in 11.19? So I cannot just say var player. So how I make them variable, I forgot. Let's see in the docs. I did see that they changed here. This is like on the top level, you say it's a variable, not on the... Okay, let's try this. And now because it's variable, I might have different kinds of problems. Yeah, so because now I'm trying to do this here, and that can be only done with constants. So maybe we'll have to push this history down for that reason. Let me see what you guys write. Andre says it will probably be 0 for global variables. This is the previous thing. And really undefined for local variables. Yeah, we read that. Fields by default are not constant, and you can't make them constant. So what was the problem then? Let me see. If I did this, why it said constant and to constant dot turn, then it means something different here is constant, not the field itself. It's pointing to this dot. That should probably be my hint. Just one more time, compare what they do. So they take the reference to pass this, but do they do something outside the function, just like a simple assignment, just to see if they are doing such thing? Okay, here they receive the vector, they just return, they don't change it. Here they initialize. Okay, not what I want. So only here in this function, they are assigning it once they have the reference to a struct. Okay, so then they say point y equals y. So they literally use the struct and they use the dot notation to access the field. Then why this does not work for me? What am I missing? Let me see what you guys wrote. It's history variable being constant. Ah, sorry, yeah. I forgot about that. Yeah, because I'm trying to change something in the history, not... Yeah. Where is my history? Here. So if I put it as a variable, then I'm going to have different kinds of problems. So let's see. Use size. Now it's a different kind of problem because I have to have this as U8. So let's cast it where it was here. So let's do what will happen if I say int cast. I forgot what this one does. Oops. Will it automatically find the correct type? Or I will have to specify exactly. Oh, it did. Okay. Okay, nice. And now if I print the history turn afterwards, so let's do here after. Yeah, now it's finally changing. So let's print just for the sake of experimenting. Let's do this before the game over, that I can see all of them, not only the turn, but the entire structs in the history. Okay, now I have a different error here. What does it say? So this ASM volatile. What did I do? I try just to move this on some other place. Let's say it's the end, just to see something. Yeah, definitely doesn't like it. What does it say? Out of bounds. Where? Aha, this is a different thing. Turn. Ah, okay, yeah, of course, because I have 15 turns. Okay, so let's just do a simple break here. So just for now, just to see how this looks like. And of course, this will be... This because we don't have the winner check now, this is the problem. So it will not do this once we have, like in the version of tic-tac-toe before, the valid winner check, because then it will not let this go more than safe. But in this case, it's not safe yet. So let's say here, after we finish somewhere here, for example, let's say if turn, how it's called, turn equals, so it starts as 0. So let's say when it's 13, we will break here. Let's see now. And then now turn 0, turn 1, turn 2. Okay, perfect. Up to 13. Perfect. Okay, this is what I wanted. Yay! Thanks, Andre. You helped a lot. Okay, let me think, because I'm already 1 hour and how many minutes? 40 minutes into this stream. There is no way I can finish this now. Today in the next 1 hour and a half maybe. But I don't want to make this a long stream. So I believe I will pause here. And then next time I will see when I will do next. Maybe I'm not sure if I will make it tomorrow. So I will let you guys know in the regular streams when I will finish this up. But for now I will stop here with tic-tac-toe. Oh, sorry, with the N in line. So what's next? So this history thing now takes in turns, and the player and all, now it's going to be easier because I made this work for this simple thing. So it's basically the same for player, and this was the hard part for me, at least now. And the winner check, this is pretty much reading from the multi-dimensional array. So this writing part was a bit trickier for me, and also here defining this was a bit trickier. But reading part, it's not that hard. So this is a template to read anything. So it's just like the math thing to calculate which is the first index and which is the row index, which is the column index. So I believe also Robert has math here in the code, and I will do a bit different now because it's a bit different. But this is not so hard. So I believe I can finish it next time, so that if I have 1 hour and a half, let's say, of a stream, I should be able to have a prototype, a working prototype of this N in a line. So then I will mark this probably video like part 1, at least something like that, because it's not finished at all. So previously when I did the tic-tac-toe, I didn't mark them as part 1, 2, 3, because even the first one was a working prototype. So the simple tic-tac-toe game, but in this case, this is not. So I will just write a comment that it's not finished and that it will be finished in the next stream when I go back to this. But today I'm going to do like, I'm just going to have some rest, maybe half an hour or so, and I'll make another regular 26th, I believe, day of going through the docs and learning more Zig. But this was so interesting, and it was so helpful to practice these things and to understand better how they work in Zig. Let me see what you guys wrote. Andre said one more thing. Why turn number is up to board size? It seems to be unrelated. Yes. So turn number is, this is the idea is that this is the maximum turn number, so that we don't have it can be theoretical while true, and then you break it when there is a winner, or when it's full. You can detect it's a full board and break. But of course, in this case, it's very specific because of this. It's not realistical, so it's not unpredictable at this point, because we know this is how many moves we have. But in the real world example, you will have a dynamic input from the user. User will say, I want to play here. And then you have to say, like, this is possible, this is not possible, and then react on that decision. And then it can theoretically happen that the users, that the players, play in such way that you don't have a winner until the end, and that you literally fill in all the fields and that you don't have a winner, so that it's a tie. And in that case, it would be the board size. So that's the maximum allowed repetitions for game loops, if you will, for this game. But of course, because in the working version, there will be this check. So like what we have here for tic-tac-toe. So there will be this check if there is a winner, this one here, which will break the loop. So it will not go outside of the range. And there will be no range of moves. There will be no moves predetermined. Like in this case, this is just like, for now, before I process the user input, this is predetermined. But in the real world, it will be some kind of prompt to a user. So like, where would you like to play? Which column would you like to play? and then the user will type 1, 2, 3, whatever. So then technically I will have to change, then it cannot be no, so this input, at least for the user, it cannot be known if the user will try 50 times or 5 million times to do something that they shouldn't. So if, let's say, if the first column is full and then the user tries to put in the first column over and over again, so that has to be something like a infinite loop, while loop, that you break once the conditions are correct. But as for the maximum number of moves, it is okay. It can be the number of elements in the board. That's the maximum. Anyways. Okay. Thanks, guys, for being here with me as I try to do this an inline game, which I haven't finished. So next time I will finish. And I will, like I said, in like 30 minutes or so, I will do a regular stream. And I will go through the Zeek docs to see what's next on what is next on the menu. Thank you one more time for being here, and see you soon. Bye bye.